Student, I am K. Boopathi, Assistant Professor in Physics, Bharathiyar Arts and Science College for Women. Today we will discuss about the topic is basics of fluorescence and phosphorescence. So before starting with reset, let us understand some terms. We all know that the electron present in the atom, our specific spin associated with them. These electrons there themselves with electrons having spin opposite to pair. As a result, any pair of spin is 0. When the electron of pair with the electrons having opposite spin, they are said to be singlet state. However, certain time arises both the pair of electron having same spin. Such a state is called triplet state. Looking at the energy level diagram, we can try to understand the basics of fluorescence and phosphorescence. The energy level diagram helps one understand introductions of phosphorescence and fluorescence. As seen in the diagram, different energy state. In the ground state of molecules, molecular energy is constant and possesses minimum value. When an external radiations or EMR fall on the molecule and absorb the external EMR, due to the absorption, the electronic transition takes place to higher state. Like second electronic singlet state and first electronic singlet state are depicted in the diagram. It should be noted that the electronic transition occur only the specific molecules and only bombarded by the specific wavelength of EMR. This is because only the radiations of specific wavelength and energy of the characteristic structure. As seen in the diagram, lambda 1 refers to the wavelength of the light and absorbed by the molecules. It transition to refers to the first electronic singlet state. The excited singlet state after a sudden time in order to be 10 power minus 8 to 10 power minus 4 second. After a short time interval, the electronic turns back to the ground state. This transition energy is released in the form of emission. This phenomenon is called fluorescence. This transition involves less energy to the original absorption. So the emitted wavelength is less than the absorbed wavelength. This refers to lambda 3 is greater than lambda 1. One can perform qualitative and quantitative analysis can be performed using the fluorescence process. Sometimes the electron instead of first electronic singlet state to not to the ground state, it goes to the first electronic triplet state. Stays sometimes and to come to the ground state due to the transition in the form of emissions. This phenomenon is called phosphorescence. Phosphorescence helps to analysis of the analyte. Fluorescence is immediate emission of absorbed radiations and phosphorescence is the delayed emission of absorbed radiations. We are going to fluorescence spectroscopy. It is also known as fluorometry or spectrofluorometry. So first of all, what is fluorescence spectroscopy? Fluorescence spectroscopy is a type of electromagnetic spectroscopy that analyzes fluorescence from a sample. So we now let us see the principle of fluorescence spectroscopy. The principle of fluorescence spectroscopy is based upon Chopolensky diagram. We know the word of Chopolensky diagram. When a particle absorbs ultraviolet or visible light and undergo electronic transition from lower energy level to higher energy level, this absorptional light requires 10 power minus 15 seconds. It emits the radiation which is called fluorescence. The fluorescence spectroscopy is based upon the same principle. Now let us study about the instrumentations of fluorescence spectroscopy. Components of instruments are light source, monochromator. We are two types of monochromator, excitation monochromator radiator and emission monochromator. So, we study the difference between two monochromator later. Sample holder, detector, readout device. So we now the study about the working of instrument fluorescence spectroscopy. The basic requirement of light source. The light radiation is passed through the excitation monochromator. Only the specific wavelength of radiation is passed through the sample holder, which record the excite the molecule to the atoms. In the emission of the emitter radiation is passed through the emitter monochromator, where the emitter radiation is sampled from passed through the detector. The detector is passed through the electrical signal to the readout device to display the form of graph. So first of all, let us see the light source. Xenon arc is mainly used as light source. It is used to produce continuous spectrum. The light radiations are produced in the range of 300 to 800 nanometer. Let us see the detail about monochromator. Monochromator is mainly converts the polychromatic light to monochromatic light. Only the specific wavelength of light passed through the sample holder. Now the fluorescence spectroscopy, two types of monochromator. First is the excitation monochromator. Second is the emission monochromator. Excitation monochromator, it allows only the radiation which excite molecules or atoms. The emission monochromator, it passes radiation only emitted by the sample molecules to the detector. This is the basic difference between the two monochromator. Now the sample holder. Cavity made up of quartz or glass tubes. It could be square or cylindrical in shape. Now let us see about the detector. It will convert light energy into electrical signal that are displayed on readout device. PMT, photomultiplier tube, is commonly used as detector in fluorescence spectroscopy. The N component of readout device. The output current from the detector is fed into the measuring device that indicate the extent of fluorescence produced by the sample. Now the one important unit thing, the fluorescence spectroscopy. The emission monochromator is always placed in the 90 degree of the excited light. This is done because we minimize the risk of the transmission and reflection of the light. Difference between fluorescence and phosphorescence. Fluorescence, it is the absorption of energy by atoms or molecule followed by immediate emission of light or electromagnetic radiations. Emission of light suddenly stops on removal of source of excitation energy. Phosphorescence, it is the absorption of energy by atoms or molecules followed by delayed emission of light or electromagnetic radiations. Emission remains for some times even after removal of excitation source. Time period or interval between absorption and emission of light is very short time. Material give immediate flash or after glow on excitations. Time period between absorption and emission is long. Material appears to glow in dark because of slow emission of light. Mechanism, fluorescence. Excited atom has short lifetime before its transition to lower energy state. Transition occurs from ground to singlet excited state and do not change direction of spin. Phosphorescence. Excited atom has long lifetime before it transition to lower energy state. Transition from single excited state to triplet state without change of spin. Mechanism. The atom goes to second electronic singlet state and the atom goes to first electronic singlet state. First electronic singlet state to inter-system crossing system, and the process is called phosphorescence. First electronic singlet state to ground state, this process is called fluorescence process. Applications. Fluorescence microscope, filter fluorometer, spectrofluorometer, fluorescence microscope, fluorescence scanner. Protein conformation, genetic engineering, DNA analysis, enzymatic reactions, membrane viscosity, membrane transport. Examples: fluorescent jellyfish, chlorophyll, extract, vitamins, gemstones including gypsum, talc, etc. Fluorescence, glow of clock dials, material in signs board, illuminate of light. Thank you.